All right, so we're going to talk about something kind of new for you guys. All right, we're going to be talking about Cramer's rule. This is going to apply to 2x2 matrices. All right, so what it is, it's it's another method for solving a system of equations. All right. Now, I know we've already solved systems by graphing. We've solved them by what they called substitution. Substitution was where you would solve for one of the letters, X or Y, and then take that answer and plug it in for the second equation, X and Y, or X or Y. Then there was the elimination method, and that's what I'm going to be using here. So I'm going to come back to this, but before I do that, I need to refresh you on the determinant of a 2x2 matrix. All right, so the determinant is it's a tool to determine if a system can be solved. So what we do is we multiply these two numbers, AD, and then we subtract B times C. So let's say you had matrix 1, 6, 3, 4. You would do 1 times 4 is equal to 4, and then minus 6 times 3, that's equal to 18. So the determinant comes out to be negative 14. That would be the determinant of this. Now the shorthand notation that they do is instead of writing out the word determinant, they put it in these little bars, kind of like absolute value bars. And we say the determinant of this matrix is negative 14. Okay? But the determinant we're going to see is actually going to be very useful in solving this. All right. So what I'm going to do is I'm going to solve this system of equations, and this is actually going to apply to every system of equations, right? Where it's written in standard form, some number times x plus or minus some number times y. And remember, these numbers over here don't really matter too much. All right. What I'm going to do is I'm going to make the coefficients for x, I'm going to make them the same number. All right. Actually, what I'm going to do is I'm going to multiply the top equation by negative c, right? And I'm going to multiply the bottom equation by a. So this is going to give me, for the top equation, it's going to be negative acx plus, we'll distribute that in. Actually, it's going to be minus, isn't it? Minus bcy is equal to negative ce. And then on the bottom, we get positive acx plus ady is equal to af. All right, so just follow with me here. It's kind of a weird process, but it's just algebra. We're going to add these two equations. So when we add negative acx to acx, those cancel. We did that by design. So what we're left with is this little combination right here. I'm going to write the positive one first. Ady, and it's going to be minus bcy, because we're just adding the two equations. Af minus ce. Okay, I'm going to solve for y. Notice that these two terms have a y in them, so I'm going to factor the y out, and that's going to leave me with an AD minus a BC. And we still have the same thing over here. Okay. To solve for y, I need to divide by whatever's attached to it here by multiplication. So I'm going to divide by AD minus BC. AD minus BC. Okay, so these are going to cancel. And you're going to get y is equal to this right here. AF minus CE over AD minus BC. All right, I'm going to hold on to this. All right, so I got it solved for y. Now I'm going to go back to the same equations, the same system. AX plus BY equals E. And we had CX plus DY is equal to F. All right, but this time, instead of canceling out the X's, I'm going to cancel out the Y's. And in so doing, we're going to be solving for the X. All right, so I'm going to multiply my top equation by negative D, and I'm going to multiply the bottom equation by B. The reason I did the negative is so that I can add the equations. Doesn't really matter. I mean, we could have multiplied by D and B and then subtracted the equations. Doesn't matter. All right, distribute here. We're going to get negative ADX for that term. And then it's going to be a minus BDY is equal to negative DE. On the second equation, we're going to get BCX plus BDY is equal to BF. All right, now we're going to add these equations so that these y terms will cancel out for us. So what that's going to leave us with is BCX minus ADX. Right, BCX minus ADX, because we're adding the two equations, equals BF minus DE. All right, again, we're solving for X, so I'm going to factor out the X here. This is going to give us BC right there minus AD equals BF minus DE. And then we're going to divide by this. I'm going to write that over here. So if we divide by this, we're going to get BF minus DE on top, and we're dividing that by BC minus AD. And this is equal to our X here. Now, I'm actually going to rearrange this just a hair. So remember on our Y equation, our solution for Y, we had AD minus BC in the bottom. I'm going to make that happen over here too. All right, AD minus BC. The way we do that is we just we factor out a -1 on the top and bottom, or what we do really is we divide each piece by -1. So what that gives us is X equals DE minus BF, and then it's going to give us AD minus BC. Okay. All right. So I've got X and I've got Y, but here's the thing to notice. We actually have this nice little relationship in the denominator. See, the denominator should be pretty familiar to you. This is our direct formula for finding the determinant of the matrix. If our original matrix were A, B, C, D, this is our regular determinant formula. Now, I'm going to show you what this AF minus CE is and the DE minus BF. I'm going to show you that in the next video with a couple of examples. All righty.